So guys, we were studying about the TLOC extensions. So everybody has an idea about TLOCs. TLOC consists of three things, which are color and the encapsulation, and what else? Color, encapsulation, and guys.
Systematic. Sir,
Yeah. Okay. So in TLOC extension, what we were planning to do, we we have two routers. So for any site, generally what happens is, for any site, we generally have either one router and multiple internet or the multiple ISP connection terminates on the single router. So generally what happens is, whenever we have a small site, if we have a small site, then it has only a single router, because in that site we generally do not bother about the device redundancy. So if device goes down, then we do not have any redundancy in that on that site. So generally, if we have a small site, let's say we have a few users, like 10 users, 20 users, and it depends upon the type of the organization and what business they are doing. So, in general, if we have a small site, then we have a single router and multiple links are terminating on that router. But there may be a case where we have only a single connection terminates on the single router for any on any site. But it completely depends on the requirement of the business. But in general, what organizations decides to do is, for a smaller site having less number of users or non-critical site, we have a single router with one link or multiple links. So if we have a smaller site, one router is enough. Otherwise, if we have some critical site, then definitely we have multiple router for redundancy, and your internal infrastructure is just like that, and your edge routers are connected in this way. So here you have a core router, core switch, where you have all your internal devices are connected. So if you have larger site or hub site or even a data center site, we have generally have multiple routers and multiple links are terminated on each router. But many a times this multiple connection is not possible because of the either because of the business requirement or technical technical requirement, it is not required. So we have a scenario comes up like this. We have a relatively larger site where we have multiple routers and our internal network, but we have only one ISP terminating its link on this router and one ISP terminating link on this router. But in this case, if this ISP goes down, then we do not, or if this ISP goes down or this router goes down, then we do not have any connection outward. So to avoid that scenario, we have a very important concept called TLOC extension. So in TLOC extension, what happens is, if we have two routers and one link is terminating on that router and one link is terminating on this router, then we can utilize the other link to get a virtually terminated on this router. Let's say this is internet or this is MPLS, just like in our case. So what can happen? This router can still utilize this link virtually, and it will appear as if the other link is also connected virtually to this router. Similarly, on this router, we may have virtually connected internet on this router. So after our TLOC extension configuration, our, our topology will look like this. each router will be having two links terminating on each router. But for this requirement to get fulfilled, we should be having physical connectivity between these two routers. Physical connectivity means either these should be directly connected to each other or maybe via layer 2 connectivity, via any switch or something. So this is the requirement for TLOC extension. We should be having two layer 2 connectivity between these two routers. Okay. So for internal network, if let's say this link goes down from here, internet link goes down from here, this internal network or the internal traffic can still go towards this router, and from this it will still go to the either MPLS or to the this MPLS circuit or through this virtual internet circuit. So let's do this configuration on our lab. So for TLOC extension, we have a site 6 where we have two routers, 61 and 62. 61 router is connected only to internet and 62 router is connected to MPLS, only to MPLS. So this is different from what we have on all the other sites. For example, site 1, we have router 1 which is connected to both internet and MPLS. And site 2, we have two routers and each router is connected to two links. One is internet, one is to MPLS. Similarly for site 3 and 4. So if you see site 6, we also have physical connectivity between router 61 and router 62. So either you have the physical connectivity between these router 2 or you have layer 2 connectivity between these between these routers. So you may have this connectivity like this, what we have in our lab, or you could also have you could have you could also have these links connected to this switch, connected to this switch, and these are in different VLAN. So this may be in let's say VLAN 10, or this may be in VLAN 20, this may be in VLAN 10, and this may be in VLAN 20. So in via layer 2, these would be directly connected to each other logically. So that scenario may be like this, or maybe you have a physical wires connected directly between these two routers. So you may have connectivity via either of these two, but ultimately you should be having, after configuring your IP address, you should be having layer 3 connectivity between these two routers. So that is the prerequisite before starting your configuring your TLOC extension. So let's first power on these devices. So guys, are you clear what we are going to achieve now? after configuring TLOC extension, we will be having two links on this router. The first link is the physical link which is attached to the internet. Other link would be kind of a virtual link connected to the MPLS, and for this router 61, and for this router we will be having a virtual link connected to the internet. So ultimately we will be having two links. One is the actual physical link and another is kind of a virtual link, and other similarly on this. So we will be having multiple uplinks on each of the routers similar to this. But here we have both physical links, but here we will be having one physical and one kind of a virtual link. And that can be achieved only when we have a internal, these routers are connected via two links. So either two links, or you may also configure a sub interface on these links. That can also be possible. You can configure sub interfaces on one link and which is connected to the other router either via switch or directly. You can still achieve the same thing. Okay. Guys, do you have any questions on this? Now we'll start configuring our TLOC extension. So this TLOC extension is very important concept because many organizations they generally avoid having four internet links on their environment. They just have two internet links. But using those two internet links or any other MPLS or any other ISP links connectivity, they have only two links and they are terminating on different routers. And they deploy TLOC extension. So if you know the concept and if you know the configuration, then you are it's good to know about it. So let's make a simple topology of this where it's very important to plan it before configure it. So let's make a topology diagram, small topology diagram. It will be a part of your planning. It should be a part of your planning before deploying anything. So we have two routers. One is 61 and one is 62. And these are physically connected to each other. So that may be a logical connection. And one link is terminating on this, one link is terminating on this. For 62, it's a MPLS, and this is internet. And here on 61, we have this interface. This is actually nothing but gig 0 by 0. And this is also gig 0 by 0, right? And these internal links are gig 0. I'm not writing G, I'm just writing gig 0 by 1. And this one is gig 0 by 2. This is again 0 by 2. Let me zoom it. I think this is, I'm unable to see it properly. I think this is E2, this is E3, and this is E2. So E2 means gig 0 by 1. So 0 by 1, 0 by 2, 0 by 1, right? So this is how these are connected. And let's take a subnet. On this link, let's take subnet of 160.0.0.0/24, 170.0.0.0/24. This is, let's say, dot 61. So need not to write it. Whenever we have a router 61, the last octet would be 61 only. Either in this subnet, or the link which is going to internet or MPLS. So this is dot 61 and this is dot 62, and we have this subnet. So what we have to do is we have to create templates wherein we will be configuring our IP interfaces, this one, this one, this one, and this one on 61 and 62 respectively. And here what we are doing is we will be extending this interface. We will be extending this interface, which is gig 0 by 0, on this interface. So we are extending this 0 by 0 to be used as a TLOC extension on this 0 by 1. Similarly, we are extending gig 0 by 0, and we are extending this TLOC towards our other interface, which is gig 0 by 1. If we have extended this interface towards to our gig 0 by 1, that means this interface, which is 0 by 2, going towards 61, should be our, guys, this should be our what?
It's a virtual link
TLOC extended.
on
Yeah.
61. Yeah.
No, this is our TL. See, guys, keep participating. Okay. So this link, we are extending this link to our gig 0 by 1, right? So
Right.
I tell you, this is our cloud here, right? And we have this interface as a tunnel interface, which is going towards an ISP. Okay. Generally, we configure like this, right? We can always configure these links as tunnel links. We always configure these as tunnel links. But now in this case, we have extended this interface towards to our gig 0 by 1. That means we have to configure this link which is going towards 0 by 1. So that link should be a tunnel link, right? Very similar to what we have a tunnel link for this towards our ISP. So for this router 62, this 61 interface, this is an ISP for us. For ISP for 62. So gig 0 by 2 going towards an ISP, we configure this as a tunnel link. Similarly, this 62 interface 0 by 2 going towards an interface which is kind of a ISP now, because we have already extended this link towards to 0 by 1. So this interface will be our tunnel interface now. Tunnel interface. Similarly, we have extended our MPLS 0 by 0 link to 0 by 1 on 62. So that means this interface towards towards 62 should be our tunnel interface. Tunnel interface. So if you see it now virtually, it will be like this. It will be like this. We have an ISP. We have an ISP. Let's not draw this, otherwise we will be. Let's rub it. Mm. Okay, so this interface, this ISP is connected to 61, and we are extending this 0 by 0 to 0 by 1. And now this router, this interface will be acting as an ISP for 62. That's why we will be configuring tunnel on 0 by 2. And similarly, we have extended 0 by 0 to 0 by 1. And this 0 by 1 of 62 is acting as an ISP for 61. And that's why we configure tunnel on this link. Okay, so this is the configuration wise. What else we are required to do now? So when we configured our ISP and this router interface, this, what else we did? We also did routing, right? If you remember, we also did routing, and we provide a static route towards our ISP, right? We did a routing on this, and we provide a static route towards our internet. And similarly, on this router, we provide another static route towards our MPLS. So we also did routing in VPN 0. And this routing is required for what? To achieve the basic connectivity, right? So similarly, we also require routing on these routers in order to reach to the respective ISPs. For example, now this is a tunnel interface on 62. We should be having a static route to move all the traffic towards 61 first and then towards the ISP. So we should be having a static route on 62 which moves all the traffic towards 61, and ultimately it goes to an ISP, internet ISP. Similarly, on this 61 router, we should also be having a static route or default route pointing towards 62, and then it will move the traffic from 62 to the MPLS, right? And the last thing which is required, now these two ISPs do not know anything about these networks which we configured, so 160 and 170. Then how the return traffic will come to the 61 or 62? So we have to advertise this 160 and 170 network into our ISPs so that return traffic can come to these routers on these links, on this 160 link and 170 link. So it will not happen without advertising 160 and 170 network. So if you have any dynamic routing running between ISPs like BGP or anything else, you can advertise this 160 and 172 on this OSP or BGP so that ISPs can have those routes. But in our case, we are not running any dynamic, and generally in most of the cases they avoid static route dynamic routing, and we have a static routing configured everywhere. So we will be configuring 160 and 170 statically configured on these ISPs, this one and this one, so that return traffic for these network can come back on 61 and 62. Guys, any questions so far?
These 160, these in between these two interfaces, we need to
Mhm.
put the default route or specific routes
Where?
between 61 and 62.
Yeah. So
We can put
specific
the
route,
specific
you
routes.
you cannot put a specific route because ultimately you are going to internet, or you are going to internet. So you have to send your all your traffic towards towards your ISPs. So you have to configure a default route, not a specific routes. Just like in this case, what we are trying to do, we are sending all the traffic to the internet, and to send all the traffic to the internet, we have to have static default route, just like in this case. So similarly, when you are configuring your this link as a tunnel link, or this link as a tunnel link, you should be forwarding all your link, all your traffic to an ISP, internet ISP. The only difference here is you are just extending this interface or the TLOCs to from 0 by 0 to 0 by 1. That is the only difference. Otherwise, you have to have a default route which will send all your traffic towards 61, and ultimately it will go towards your internet ISP. So you have to have default route similar to this. So it has
Okay,
no specific routing is required, only default route is required.
got it.
So
Okay.
you can take this as very similar to this one. In order to send all your traffic towards your internet, you have to have default route. So here you have to send all your traffic towards your internet, you have to have default route here and default route here. Okay, but other than this, you have 160 network and 170 network which you configured between these two routers, but nobody else outside your environment knows about these networks. So how people sitting on the other side of your other side of, in other sites of other branch sites, then how these people come to your network, this network? They have the default route. They have a default route which send all the traffic towards your ISP. So ISP must be having these routes 160 and 170. So how these ISP will get to know about these? Either you advertise it in your dynamic routing protocol, but in our case, on most of the cases, dynamic routes we do not generally configure. So what you have to do, you have to provide a static route, a specific route, which is 160 and 170, so that all the traffic coming from other branches to reach to once reach to the ISP, they can send it to your 61 or 62, and they will send it to this only when they have a specific route 172 and 170. Okay, so let's configure this now step by step. See, this is at first this looks very complicated, and but configuration wise, yes, configuration wise it is little complex at first, but it is very important concept. So I have worked with the 3-4 organizations where I deployed design and deployed this SD-WAN, VIPTEL SD-WAN, where whenever we have multiple routers on any branch, they do not have multiple links. Instead of having multiple links terminating on each router, what they do, they terminate single link on each router and configure TLOC extension. But this is a one-time activity. You are not supposed to do it again and again. So you will in next few years you will probably never get a chance to configure TLOC extension. But if you know how to configure it, you will be easily, you can understand and troubleshoot. Okay, so let's configure it. Uh, and obviously we will not be configuring it via CLI, because these routers, if I remember correctly, we have already these routers discovered on this, and we have already configured the basic configuration on these routers. Let me go to the vmanage. Mm, Let's not rub this because we will be requiring these IPs and interfaces. So let's go to okay. So this is our dashboard. We have two routers up, vSmart up, vBond up. So guys, recently I also noticed one thing. Uh, Sometimes not sure the reason why, but sometimes uh, this maybe the browser or maybe the machine creates an issue. uh, what I have seen recently that these routers are shut down, all these routers are shut down, and only two routers are up, and still this your vmanage GUI vmanage showing four routers here. So not sure the reason, but a quick resolution for this, you just go to your browser and erase the cache from here. So you can find out where the cache is or history. You can remove the history and then again log in into the vmanage, and this issue will get resolved. So this is very specific. Sometimes it happens. So make sure your cache is cleared and then you can further troubleshoot your problem. Okay.